Lesson 12-2. Analyze arithmetic sequences and series. An arithmetic sequence has a common difference between successive terms, meaning you're always adding the same thing to get the next term. You add the same number each time. So like 3 plus 6, or 3, 6, 9, 12, 15, right? Keep adding 3 on that one. 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15. So our D is 3. You could always figure that out by taking one number and subtracting the previous. 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3, and so on. So is this one arithmetic? Negative 10, negative 6, negative 2, 0, 2, 6, 10. Well, let's see. I add 4. I add 4. Looks good. I add 2. Wait, what? 4, 4, 2? Those aren't the same. No, it's not. How about this one? 5, 11, 17, 23, 29. Is that arithmetic? So 5 plus 6. 11 plus 6. Plus 6. Plus 6. Yes, that one appears to be adding the same thing. We're always adding 6. So yes, and our D is 6. The formula for the nth term is this. Anybody care where it comes from? Well, let's see. Let's say we had 3, 6, 9, 12, 15. Well, this would be plus 3, plus 3, plus 3, plus 3. So what we have, to get the 3, it's just 3. To get the 6 is 3 plus 1 times 3. To get the 9 is 3 plus, and there's 1, 2 times 3. To get the 12 would be 3 plus 1, 2, 3 times 3. To get the 15 would be 3 plus 4 times 3. So this would be 0 times 3. So what we have is we have our 3 plus our n minus 1 times 3. So that's our A1. That's our A1, and that is our D. So it's A1 plus n minus 1 times D. So write a rule for the nth term of this arithmetic sequence 32, 47, 62, 77. So you have to decide, what is our D? Oh my, if you don't know, then you can say, wait, 47 minus 32 is 15. And we see, how about 62 minus 47? Is that 15? Why? Yes, it is. And 77 minus 62 is also 15. So our D is 15. And then your A1 is 32, so we can fill in the formula. So it's AN equals A1, n minus 1 times D. So this is A1 and D. We could distribute the 15. Give us 15n minus 15. And then we can combine the 32 and the 15. 32 minus 15 would be 17. So it's 17 plus 15n, or maybe you wrote 15n plus 17. One term of an arithmetic sequence is A8 equals 50. The common difference is 0.25. Write the rule for the nth term. Well, we have to decide what we know. What we know is when n is 8, an is 50. And we know this is D. So if I take my rule for the nth term, an equals a1 plus n minus 1 times d, and I fill in what I know. I know an is 50, I know the n is 8, and I know the d is 0.25. So I fill in all those. Then I can solve for a1. So 8 minus 1 is 7 times 0.25 is 1.75. This part there. Subtract the 1.75, and a1 becomes 48.25. Now I know my a1 and I know my d. So now I can take my rule for the nth term again, and this time fill in the a1 and the d. Distribute. And then combine the 48.25 with a minus 0.25, and you get 48. So 48 plus 0.25n. Or maybe you put 0.25n plus 48. Two terms of arithmetic sequence are a5 equals 10 and a30 equals 110. Red rule for the nth term. Well, we have 2 points. We've got a point here where n is 5 and an is 10, and there when n is 30, an is 110. So if I take my first point and fill it in, so the n is 5, the an is 10. 5 minus 1, of course, is 4. I ended up with that. If I take my other point and fill it in, an is 110, n is 30. So an is 110, n is 30. 30 minus 1, of course, is 29. And so now I have these two equations. That looks like a system of equations with two variables. So we could solve those with, say, linear combination. I could eliminate the a1, so I'll multiply this first one by a negative 1, so I can eliminate the a1. Add those together, looks like we'll have 100, the a1s are gone, and 25d. Divide by the 25, and d is 4. To find a1, take one of your equations and plug it in. So I'm taking the 10 equals a1 plus 4d. Plug in the 4 for the d. Looks like a1 is negative 6. So now I know d and I know a1. Let's fill in this formula to find your rule. An equals a1, which was negative 6, plus n minus 1 times d, which was 4. Distribute. And combine, so negative 6 and negative 4 make negative 10. So you get to say negative 10 plus 4n, or 4n minus 10, same thing.